Okay, guys, today we're starting Unit 9, and that is our polar unit. So, looking at this document here, we're going to start with talking about something we're familiar with, which are rectangular coordinates, because polar coordinates are just a new way to write rectangular coordinates, but they use angles and a radius, so building off of circles a little bit here. We'll also use a lot of trig in this unit and our unit circle as well. So our first section here is just referring back to rectangular coordinates. Now, rectangular coordinates, again, that's what we're familiar with. So when I'm plotting something on a rectangular plane, we have our x and our y axes, and we know that the center is the origin. If I have a point out here, it'd be x, y. X is that horizontal distance, and y is the vertical distance. Now, our new system of plotting points is polar. Okay, so this time, instead of an x and y axis, we're building something off of the center, which is called the pole. That's why it's polar coordinates. And if I have a point out here, it's actually measured as the distance from the center. So in that case, it's the radius and the angle, theta. So our angle is just like our angles that we've been using all along. So how far away we are from that horizontal axis, moving counterclockwise for positive angles. So again, r is the radius and theta is the angle, and we'll look at angles in degrees and radians. Okay, so the first topic today is just plotting some points. So we're going to identify the angle first. If we have a positive radius, we'll go towards that angle, however many units, and a negative radius will go away from the angle. So for example here, if I'm plotting each point, point A is at a radius of 3 and an angle of 30 degrees, r comma theta. So I'm going to find the 30-degree angle first. This blank graph here is a polar graph. Notice it's built with circles. So 30 degrees is in that first quadrant. Radius of 3 means count 3 units away. So that would be point A, away from the pole. So going towards the angle because it's a positive r. Point B has an angle of 240. That's down in quadrant 3. And I'm counting 5 units towards that angle. So that puts me out here. Point C is at 135, which is in quadrant 2. And I'm counting 1 unit towards the angle. Now, point D, I have a negative angle. So if I have a negative angle, I'm going to start by finding positive 60 degrees. Positive 60 is in quadrant 1. We know negative and positive angles are directly above and below each other. So if the positive angle is in quadrant 1, the negative version of that angle will be in quadrant 4, in like the same corresponding spot. And then I'm going to count 2 units towards that angle. Point D. I want to add one more point here. Negative 3, 330 degrees, just to practice a negative radius. So I'm going to find the angle first. 330 is in quadrant 4. And then negative 3 says to go away from the angle. So if I highlight the angle going all the way across, I'm going to actually end up in quadrant 2. So I'm going to count 3 units going in quadrant 2 on that same angle. So I'm up here for point E. So negative radius goes away from the angle. Now, the second group, I'll do a couple of them. We have our angles in radians. So it's same exact process. Again, r and theta. So I'm going to identify my angle first, pi over 2. That's the same as 90 degrees. And 5 units towards pi over 2 gives me point A. And then pi over 6 is the same as 30 degrees, but this time I have a negative angle. So I'm going to go 3 units away from pi over 6. 6. So 1, 2, 3 puts me right here for point B. Okay, I want you to pause the video and try the next 2 points on your own, and then you can play it and check your answers. So you guys can check your answers. Mine are in purple here for points C and D. Okay, our last topic today is naming polar points. So polar points are a little bit different than rectangular points. When you have something in a rectangular coordinate system, there's one exact name for that point, and that's the only way you can name it. Like 2, -3 is in the same spot no matter what. Polar points actually have an infinite number of names because you can continue going around the circle with different angles that end up at the same spot, right? So we typically list 4 of them, thinking kind of like one for each quadrant. A little template that might be helpful. We'll always have positive radius, positive angle, positive radius, negative angle, negative radius, positive angle, and negative radius, negative angle. And we'll look at that in a moment here. Okay, so let's look at some examples. Here we have a graph. 3 points are plotted on this graph. For number 1, we're going to list 4 points in degrees for point A. So here's point A. Now I usually start with the most basic version, positive radius, positive angle. So from my unit circle, this is a 60-degree angle, and I can see that it's 2 units away from the pole. So my first point would be radius of 2, angle of 60 degrees. Now I know my next point is also going to be positive, but I'm going to have a negative angle. So to figure out that negative angle, I'm going to think about the corresponding angle that's directly below. So that would be this angle right here. Now in quadrant 4, this is a 300-degree angle. But when I use it to name my polar point, I want the negative angle, so I still end up in quadrant 1. So it'll be negative 300. Okay. Now I'm also going to need a point representing quadrant 2 and quadrant 3, and those are each going to have a negative radius. Because I know if I was in quadrant 3, so if I highlight this angle, and I end up down here in quadrant 3, if I have a negative radius, I'm going to go away from that angle back up towards quadrant 1. So if I think about what this quadrant 3 angle is as a positive measure, this is our 240-degree angle. The corresponding angle up here in quadrant 2 is 120, but I want the negative version to keep me in quadrant 3. So now I can just kind of quickly plug these 2 angles in. So I have -2, positive 240, because that would push me away back into quadrant 1, and -2, negative 120, which would also push me away and back into quadrant 1. Okay. Then I have my radian example here. So when I'm doing in radians, it's pretty much the exact same process, except I have radian measures instead of degree measures. So we're looking at point B. I see point B is down in quadrant 4. So I'm going to start by labeling that angle as it is. So down here in quadrant 4, in radians, this would be our 11 pi over 6 angle. And it looks like that is 1 unit away from the center, from the pole. Okay, now to get another positive radius, I'm going to have a negative angle. So I want the angle that is directly above, which is pi over 6. So in radians, it's going to be negative pi over 6. And then I'll have 2 points with a negative radius. Those points are going to be from quadrant 2 and quadrant 3. So you can trace the angle here. I would suggest you do that. It makes it a little bit easier to see what's going on. So my positive angle would be from quadrant 3, and that's going to be our 5 pi over 6. So I can plug that in right away. Our negative angle is actually going to be from quadrant 4, down here directly below. And that's our 7 pi, whoops, wrong way, 7 pi over 6, sorry, this one. Okay, so when I plug in that measure, it's negative 7 pi over 6. That would get me back to quadrant 2. So negative 7 pi over 6. Those are my 4 points for my radian angle for point B. Now lastly, I want you guys to try point C on your own. Okay, and then, so pause the video, try that problem, and then when you play it, I'll have the answers up. For point C, now that was a 270-degree angle. So we're basically using 270 and 90 and negative 90 to write our 4 points here. So you can see my labeling up at the top. So remember, I want to go away from these top two angles and toward the bottom two angles.